As we stated before, every file and process has a default security context. We are going to discuss what a security context looks like and how to view and modify them. Usually, a file will inherit a directory security context. A good example of this is the /etc directory. We can view the etc directory's security context with the following. The -z option is what gives us the selinux security context on a file or a directory. Here is our security context for the etc directory. A security context is broken down into three components. First, we have the user component, which refers to the type of user that is logged in, then the role component, which indicates the purpose of this file, process, or user. Then we have the type component, which is the most important field since selinux is a type enforcement system. As we can see, the security context type for our etc directory is etc_t. As we said before, most items inherit the context of the parent directory. Let's take a look at a file within the etc directory that demonstrates this. We can see that our etc services file has the same security context as our etc directory. However, there are some files in the etc directory that will have their own special security context due to the roles they perform. For example, let's take a look at the etc shadow file. As seen here, the shadow file has its own security context, specific to the shadow file. This makes sense considering that it holds the encrypted passwords for the users on the system. We can also view the security context for a running process. We add in the same Z option to view the security context for our PS command, which we will see more of in a later video. Notice the contexts that say unconfined? These are processes that are not protected by selinux since there is no policy written for them. Anything marked as unconfined T falls into that category. We do see that the Getty processes have their own security context. Now, we are going to break the SSH service on our system so that we can see why security contexts need to be properly configured and what we need to do to fix them. First, we will stop the SSH service. Next, we will see what the security context is for our SSH service configuration file. Here we can see that the type for the configuration file is that of etc. We will use the chcon command to change our security context on our file. We are using the -- reference option, which tells chcon to make the security context of our sshd_config file match that of our anaconda file. So now let's take a look at the security context for our sshd_config file. And we can see that it is now switched to admin_home_t. So let's see what happens when a file context on a configuration file that a service depends on is not what the service expects it to be. And we see that our attempt to start the service has failed. Along with that, we see that we have an access vector cache, or AVC, denial message at the top. In the following video, we will see how to use the AVC message to troubleshoot and fix our issue.